Hi, I'm Chet Udell, Director of the OPEnSampler, and I'd like for you to meet Bertha. This is our water sampler, open source, and she has 24 bags here that are hopefully going to be airtight eventually. We also have a series of 2 peristaltic pumps that are mounted on the top working in parallel to pull water out, about 250 milliliters of water for every 2 minutes. We made a customized PCB board here. It's basically for all of the control signals, turning pumps on and off. We have our motor driver and an Arduino Uno. Let's take a glance at the front end of the profile. So looking on the inside here, we have this bar going all the way down the middle we're calling the spine, and the spine has these 24 valves attached. Each of these valves are feeding from the main line into its assigned bag. We also have a flush valve that basically is just a pass through from the intake to the outlet. And what this is going to allow us to do is do a complete system purge when we're getting ready to take a new sample. And so we can completely clean the lines out and have a fresh new sample. And so I'll go ahead and just get her started. So I'm going to plug this in and open up the serial monitor so you can see some of the stats. But basically on startup, if you have it plugged into the serial monitor, you'll be able to see the flush duration and the sample duration in milliseconds. The next bag it's going to sample is number 2. It's going to set the alarm for a new time here, and this is in 24-hour time, so this will be 3:59. And it's going to basically give us all kinds of status about its electronics and the status of the valves. And right here you'll see the processor is awake and standing by for serial commands. So there's actually 2 modes that Bertha can operate under. One mode is its normal functioning operating mode, and that is controlled by the switch here, on or off. And so when this is rocked into the on position, Bertha will go ahead and start up and proceed to take the next sample if the time has passed its specified time for it to take a sample. Told us to turn the motor is turned on, and it's resetting the alarm now for 4:01. And 4:01 has happened. We got our system flush again. And the system flush is pouring out of here. So 20 seconds later, it will begin to sample bag number 4. So bag 3 was here, now bag number 4 is right here. And kind of feel it filling up as the water is being forced into this bag. Alright, that's all good and fun. So how do you tweak Bertha's parameters? We'll go ahead and switch our mode from standard operating mode to what we call the serial mode. And the serial mode will allow us to send serial commands over USB currently, but we're hoping to add a cell phone feature in order to send commands over Bluetooth. And this will allow us to tweak her settings, things like flush duration, sample duration, setting alarm periods and different scheduling systems. So I'm going to wait for this to finish sampling its sample cycle, and then I'll flip the switch. And when I flip the switch into serial mode, you'll notice that this thing here says sampler's time functions are disabled, processor is awake, and standing by for serial commands. What it means by the processor being awake is in order to conserve battery when it is in its standard operating mode, when it is not taking a sample, the processor falls asleep and shuts down all the electronics necessary for it to continue living a nice long life when it's running off of battery power. But when you're in serial command mode, the processor and all of the electronics are awake because it assumes you want to mess around with things and see what's going on. And so while you're in this mode, I've created a set of serial commands, and I've defined these in the code so you can communicate with it. And so I'll go ahead and do one thing called a reset, RST, which will do a full system default reset. CLK will give us the time of the clock and when the next sample is set. And so basically there are two ways to set an alarm. There are two alarm types. One is a daily alarm, and by default the daily alarm is the one that we'll be using, and it's set by default for 8 a.m. But let's say I wanted to set the daily alarm to go off at a different time, let's say 5 o'clock. Then I would set SAD for set alarm day at 1700 hours. And so now, if I were to flip this back into operational mode, it would proceed to take a sample daily every day at 1700 or 5 o'clock p.m. Another sample alarm type I could set is period, and that is SAP. And this is the sample alarm period in minutes. And so if I wanted to take a sample every 2 minutes, I could set that there. And so it's resetting the alarm for 2 minutes from its current clock time, 16:06. And so if I flip the switch 2 minutes from now, we would begin to take a sample again. And sample 2-minute intervals every time from there. All right, and then there's all other kinds of modes. We can set the valve number, or actually, here's another thing, the sample period. So the sample duration, sorry. So I can set the sample duration in milliseconds. And so let's set the sample duration in milliseconds for 30,000 milliseconds or 30 seconds. I can also set the flush duration. And I'm just going to set this for 20 seconds or 20,000 milliseconds. All right. And then next is I'm going to show you how to puppet string this using serial commands, and this will make more sense in just a moment. There's a few ways you can interact with the sampler in real time. First of all, you can open up valve. So in this case, I'm going to set valve number 4 to turn on. That's a 1. If I want to turn it off, I would send a 0. You can hear it click on and a little status come up, and then I'll go ahead and turn the motors on for drawing. So I'll go ahead and draw water into bag number 4. Okay. Now if I want to stop the motors or the pumps, I'll just simply type in M0. That stops it. If I want to draw water out of the bag, I'll do M-1, and this will draw water out of bag number 4. And this is going to be exceptionally useful for when you bring the sampler full of its water back into the lab, and you would rather feed samples directly into the machine without having to unscrew the bags and possibly expose your samples to the air. You can just feed it directly into the machine without having to touch the bags at all. So now that we can send Bertha serial commands, we can use any program on the computer to automate certain sample patterns. And so when you're in the lab and you want to do a system flush, or you want to fill up all of the bags with distilled water and then flush them and do several of that, or maybe an acid bath type of cleaning, you could create a program in, let's say, Python to do something similar. I made an example Python program that draws water out of every bag, one bag at a time. And so this Python program allows you to say how many bags are in the sequence, which bag you want to start drawing water out of first, the pump time in seconds, and then fill or drain. And if it is a 1, we will be draining the bags. If it's a 0, we will fill the bags. And so with this very simple framework, you can begin to create macro programs off of this that will enable you to do all kinds of things in the lab. without having to send discrete commands all by yourself. And so I'll go ahead and this program right now is going to draw all of the water out of the bags, and all you have to do is hit play, or actually you have to close the serial monitor on the Arduino IDE first. Alright, now that that serial monitor is all free, Python can now use that serial connection. First valve is opened, and now we're drawing water out of the system and in reverse back into the bucket. And in 1 minute's time, it'll switch over to valve 2, drain the water, and then valve 3, etc. All right, and those are Bertha's features, so thank you very much.